Shyster. Just quit. Kind of trippy. Hang on. Ali Ali Oxenfree, can you guys hear me? Okay. Okay. Hopefully you guys should be able to hear me okay. Just as a reminder, it's a good idea to go ahead and update your Zoom display name so that it shows your official Morehouse student name. It makes it easier for me to take attendance so I don't miss you. If it's not showing your Morehouse student name, it's a good chance I'll miss it, and it'll start messing stuff up. Um, no real announcements. Exam one was due this past Monday at 9 a.m. With all of our assignments, we get unlimited attempts, and you can actually work on them past the due date with only a 10% late penalty. So what we're doing today, we're just continuing making our way through the homework. I've just been going through as many homework questions as I can. But if you have questions over a specific question, just let me know and we can pull it up and talk about that one specifically. Um, I'm going to mute the audio so I can focus. Um, but yeah, if there aren't specific questions, then I'll just kind of make my way through as many questions. So today we were working on section 1.5. Let me do like this. So I got a couple more visitors. Okay, let me get these two. We got a few. Okay. Let's see. I'm gonna go like that, like this. I think I got him already. I got that one. I know I got him. I'm not gonna worry about it. HIJ. Okay, I got him and B. There he is. Cool. All right. So yeah, we're just going to continue. So section 1.5, I think with my students earlier in the day, like with my 9 o'clock and my 2 o'clock, we worked on section 1.4. So right now we're just going to move forward with section 1.5. Exam 2 should focus on sections 1.4, 1.5, and 1.6. You can kind of anticipate the same thing as exam 1 or something similar. The only thing different I want to do, I just want to incorporate the oral component. And for that, the main thing that I need when we start doing that, I just need to be able to see your face and you tell me what to write. Okay, so that's kind of how that goes. I see some activity in the chat. Let me check the chat really quickly. Yeah, I got you. I got you, Mr. Browner. I found it from last time. I think you might have to, like, when you log out and like you're not in my connected to me, you should be able to change your settings. You don't have to do it right now. But yeah, anyway. Okay, but yeah, I found it from last time, so yeah. Okay, so let's keep going. So again, we're working on section 1.5, and again, I'm just going through as many of the homework questions that I assigned. I think we got through all of 1.4, and so like honestly, if you want to see at least me work them, they're in the recordings. I try to make like labels. So I made one playlist with these sessions, and one playlist is like homework sessions, and there's one playlist that's specifically for the lectures, and then the other one just is like a catalog of all this kind of stuff. So this one access the graph by starting with a function from the library of functions, and then using techniques of transformations. Let me check the chat. Yes, okay. I actually got you, Mr. Jones. I got you. Like, I found I found that name on my roster. Let me let this person in. So it's okay. I think yeah. So okay, I'm gonna let this person in and keep it going. I'll just close this out. Okay. So this double bracket symbol here, this is called the step function. It's a step function. This is the greatest integer function. So like, I think we did this. We mentioned it. So greatest integer is like say it's a you wanna take the integer that's like if you land on the integer, you take that integer. Otherwise, you take the integer that's just below that number, right? So the greatest integer less than or equal to this whatever the number in question is, right? It's a step function that looks like these guys. For instance, question C, it looks similar to that, right? So whenever you get an integer, you take that integer, and then whenever you get a decimal, you just take the integer to the left, right? That's what the greatest integer function has us do. It's a step function. Normally it's filled in at 0, but we got to account for these transformations. So we have two transformations going on to the step function. We have a +3 on the inside, and we multiply the outside by 2. So if we start on the inside, so remember, inside manipulations are typically horizontal manipulations, and they are the reverse. They're typically the reverse of our intuition, right? So that +3 is going to move horizontally by 3 units. Your intuition might say, oh, it moves to the right by 3 because it's +3, but this is actually the reverse. So it actually moves to the left by 3 units. So the filled in, it should be filled in like a solid on -3. I think it's this one, right? I think this is the only one that's close. Oh, and then we multiplied the outside by 2, so that causes a vertical stretch by a factor of 2. So the only one that would move left 3 and stretch vertically by 2 is C. Let me see. I think somebody else is in the way of him. Did I lose my audio? Okay, cool. Got him. I let him in. Let me check my audio. I think I just muted it. That's fine. Okay, so let's go with C and check our result. Hope everyone's doing well. We're gonna go into the next one now. Yeah, but that's a step function. Yeah, write the function whose graph is the graph of this, but it's shifted 6 units to the left. Okay, so we're gonna start with our basic function, which is a square root function, square root of x. Now, if we're moving it left 6 units, side to side are usually inside manipulations. Even though left is in the negative x direction, because we're doing a side-to-side manipulation, it's the reverse of our intuition. So instead of doing -6, we got to do +6. Right? I think that's it. On the inside of our basic function. Okay. Feel free to either type in the chat or raise your hand virtually. Don't just because I don't see you guys, so I don't want you like waving your hand because I can't see you. I'm not doing all that. I'm just being available, really. My real intent for this time, I think I got him already. Let me just make sure. No, I didn't. Okay. Again, I just go through the questions as a courtesy, but my original intent was for this to be like a study session or Q&A. Like we don't have to talk about specifically these questions. I just go through these to kind of fill the air. And also to kind of catalog. So you'll have a copy of it. You can always pull it up later and see how I explain it. Let me check the chat. Yeah, we got you. Again, once you get into my Zoom, you got your attendance credit. Let's look at this one. Write an equation for a function that has given characteristics. This is the basic function, but it's upside down, shifted to the right units, shifted to the right by 8 units and up 7 units. Okay. So it's upside down. So that means we flipped it up and down. So that negative needs to be on the outside. So it could be any of these. Shifted 8 units to the right. So that needs to be -8. So it's either A or D. And then up 7 units. So it has to be A. Okay, cool. On to the next one. So the graph of this is blah, blah, blah. What is the equation? Okay, so let me start with the basic function. And I'm going to put it in parentheses like this. X to the power of 3, right? It says it's shifted 2 units left. So since we're going side to side, that's an inside manipulation. If we're going to the left, which is the negative x direction, it's the reverse of our intuition. So we have to say +2, right? +2. Stretch vertically. So vertical manipulations are outside our basic function. Stretch vertically, and it follows our intuition. So we're going to multiply by 4. It's reflected in the y-axis. So we need to, okay, let me think about it. This one might give me a little bit. It's reflected in the y-axis. We have to multiply the negative on the inside, but that does get a little bit. I'm going to do it like this. I think they want it done like this. I was trying to decide, do I need to distribute the negative across everything on the inside or just the x? I'm going to do it this way for right now. If it's wrong, then I'll distribute the negative on the inside, see what happens. And then shifted 5 units up. So up is the outside, so then we're going to say +5. I think this will get it. Let's try this and see what happens. Okay. So again, just stop me if you have questions or if I need to go back, or you have to get my attention. Otherwise, I'm just gonna power through. Okay, use the graph of y equals f of x to graph f of x minus 2. Okay, let me get the student, the G right here. Boom, got him, coach. Okay. F of x minus 2. Use the graph of this. Okay, so if this is the original graph, it's going to be the same thing, but it's just shifted down by 2, right? A looks like it was shifted down by 2. B is no. C is no. So like B went to the right, C went to the left, and D went up. So it should be A. Okay, let me check this one, and then let's check the chat. Okay, let's check the chat. Greetings. Yeah, if you got into my roster, you got an attendance credit. Because again, I let you guys in one by one, and I intentionally take attendance. So once you know how that story. But yeah, good afternoon, people. Use the graph of this. Okay, so we have this function f of x, but now we're multiplying the inside by a number between 0 and 1. So remember, inside manipulations are generally horizontal and the reverse of our intuition, right? So we know this is going to be either a horizontal stretch or compression. Because the number is small, like between 0 and 1, your intuition might say, oh, a horizontal compression by half, but it's actually the reverse. It's a horizontal stretch by a factor of 2. All right, I think that's how that goes. It should be a horizontal stretch. Yeah. Horizontal stretch by a factor of 2. So the y values would stay the same, but it should be stretched. It should be wider. I think it's A. A looks like it would stretch horizontally by a factor of 2. So I'm going to go with A. Okay. So these are all concepts. Okay. So we have this. So now we're doing a +2 on the inside, right? Inside manipulations are usually horizontal and the reverse of our intuition. So if this is our F and we add 2 on the inside, your intuition might think that it moves to the right by 2, but it's actually the reverse. So let me see. A is incorrect because it went to the right. B went down. C went to the left, and D went up. So the only one that went left was C. Okay. Man, we are like flying through these questions. Maybe I'll go back and work on some of the quizzes. A graph of this is given. No formula for f is given. Make a graph for this. Okay, so we have several transformations, right? So whenever we're doing multiple transformations in one go, my recommendation is to work your way from the inside to the out. So we have this f of x. We have a -1 on the inside, so that says to go to the right. So we can kind of follow the vertex, right? What is this? Is that 2? So if we go to the right by 1, looks like A and B both went to the right by 1. Okay, let's kind of get some more information. This has to go right by 1. Now we multiply the outside by 1/2, right? Again, when we're doing multiple transformations in one go, my recommendation is to work your way from the inside to the out. So we went right by 1. This says to compress vertically by 1/2. So it's like all the y's get cut in half. So it should be smushed vertically. So then it can't be B. I think it can be any of the others, right? Okay, so we smushed it. So we can at least cross out B. Next is we multiply the outside by a negative. So outside manipulations are typically vertical changes, and it follows our intuition. So if we multiply the outside by a negative, it's going to flip vertically, so it's going to be upside down. So it can't be A or B now. So it could still be C or D. And then it says to move it up by 3. Okay. It looks like D did not move up and down. It flipped vertically, but it didn't shift up and down. So the only one that did all of those, it looks like it's C. Okay. Okay, let me check. Okay, no notifications. So let F be the function that associates the employee number X of each employee of a corporation with his annual salary, F of X in dollars. Suppose each employee was awarded $800 across the board raise and an additional 6% of his or her increased salary. Write a function to describe this new salary. Let F be a function that associates the employee number X. So you take their number, and then their salary is going to be F of X, right? Suppose each employee was awarded $800 increase across the board raise, right? So you have, let me think about it. So you have the employee X, right? Each employee gets $800, so I'm going to say plus 800, and an additional 6%, so you're going to raise it even higher by 6% of this increase in salary. So instead of having 100%, now they're going to finish with 106. So we're going to say this times 1.06, right? Because we want to increase it by 6%. Okay. So instead of them getting 100% of their original salary, they're getting 6% more than that. So they're going to get 106%. 106 as a decimal, 106% as a decimal is 1.06. Write this function to describe the new salary. I think this is it. Now we just need to simplify, right? I just kind of use this space to kind of take some virtual or digital notes. Then we need to come back and like simplify this, right? So we can distribute this 1.06. So we will multiply, I think this is it. Let me go read it through it one more time. Each employee was awarded $800 and an additional 6% of his or her increased salary. Yeah, okay. So let's simplify this. So we distribute the 1.06 and we need to find out what is 800 times 1.06. So I'm just going to use my calculator. Right here. And I want to say 1.06 times 800. We get 848. When your mama tried to skate. 848. Okay. Oh, it's getting late in the day. I'm ready to stop talking. I don't want to be talking. But it's okay. What is the function that describes, I think this is it. Type an expression involving f of x. Type an answer in slope-intercept form. Do not include dollar signs. Involving f of x. We might need to change the form. Okay. 848. I would like to screenshot this, but I think we need to change the form. So let's take their original salary, which is f of x. All right, I think they want it like this. I'm going to say plus $800. So now they have their new salary, but then we want to increase that by 6%. Ooh. So we're going to say times 1.06. This is what I did before, but I didn't have the f of x part. Okay. Slope-intercept form. Maybe what I had before was fine. Can I bring it back? No. 848. Let me try the 848. The f of x is kind of throwing me off. Involving f of x. Slope-intercept form. Do not include the dollar symbol. Yeah, let me do 848. Give me a moment. Hang on. I had to take my headphone out. that just throws things off. Let me submit this first, 848. Let me see. Check the equation, write a new function. Okay. Okay. So then let's do like this. Give me a moment. Let's fix this thing. Testing. Give me just a moment. Trying to. Hopefully it'll let me fix the audio sometimes. Okay, seems like it's okay. Okay, I think we got that one wrong twice. So let's see. I feel like type an expression involving f of x. Okay, let f be a function associated. Okay. Okay. I think I'm mixing some things up. I think I got it now. So we have this f of x, all right, because that's their old salary. So we added $800 to their old salary. I think the f of x is fine. But we tried this already. Oh, okay, and then if we distribute, then we'll get this, 848 like this. So whereas before, I just didn't have the f of x. I think I was confusing f of x with x. Okay, I think we're okay. Let's try this. Okay, so it was just like the notation there. The way we were thinking was fine. It was just the notation, right? I think we had the 1.06x. They just wanted 1.06 f of x because x is the ID, but the salary is f of x, right? So that's what was going on there. Plus my little audio thing. Okay, in the given, let's see. So it says in the given graph, the temperature T in degrees Fahrenheit of a home is given as a function of time over a 24-hour period. At what temperature is the thermostat set during daytime hours, right? So this is like midnight, 6 a.m., so like around noon, right? So during the day, what is this temperature? Is that 70? That looks like 70. During the daytime hours, 70 degrees Fahrenheit. Let's go 70. Oops. Okay. Overnight. So at night, if we look at the graph, what is this? If that's 56, this is 58, so maybe 59. Man, that seems cold. If I set my thermostat like at 74, I'm freezing, and at 75, I'm like sweltering. It's so weird. We're gonna go to 59. 59, enter. Cool. What does this say? It says the homeowner reprograms the thermostat to the temperature -8. Explain how this affects the temperature in the house. This will lower the temperature by 8 degrees. Because we subtracted a positive on the outside, so it should move it down. I'm going to check my answer. Okay. So then it should be the same graph but shifted down. If that was 70, then it should go to what? 62? So 62, this one looks good. Yeah, the only one that says 62 is this one. Okay. The homeowner reprograms it to T of T plus 5. So that's going to move it left 5 units, right? Because the plus 5 is on the inside. It's the reverse of our intuition. So that will make it earlier. Move the temperature change 5 hours earlier. It's a little bit weird, but that's what it does. So it should be the same graph shifted to the left 5 units. So yeah, I think it's C. Let me go with C. Okay. Man, was that it? Oh, we finished 1.5 already? Man, we got to that fast. Okay. I don't really want to start on 1.6. Okay. I mean, I could. What I think I'm gonna do, I'm gonna go back and start working on some of the quizzes. So I'm gonna let me start with 1.4 quiz. I think that was it for that. So I'm gonna exit out of this. I'm gonna hop back over here. Let's go to assignments. And let's do the quiz for, let's start with 1.4. We'll start the test. And then here, I need to do the following. I don't know if we're going to have time to finish. It just depends. I think it's this one. Yeah, okay. And then let's hop back over here and full screen. Oh, and I need to share for you guys. New share. I still want that, but I also want this. Share too. Okay. So here, it says to write a linear function that has the indicated values and sketch the graph. Let's see. I should write, and I'm being totally lazy. Let me see the time. How much time do I have? I think we got enough time. Okay, so let me take some notes and just stop being lazy. So this is section 1.4 quiz. Let me see. If I do paper. Are you lagging? Let me reboot you. So I'm going to attempt this section 1.4 quiz just to kind of fill in some of the time. We can kind of keep working here. Paper. Okay. So, number one. This is a quiz for section 1.4. I'm just taking some notes. I'll show what I'm writing in a minute. It's kind of late. Oh no, I'll let him in today. It's fine. Okay. So question number one. I'm going to say write a linear function. All right. We have this f of -4 and we have f of 6. Sorry, let's back up. F of -4 equals 1, and then f of 6 equals 6, right? Okay. And then graph. We can get the graph once we have the function. Let's hop here like this. So these are the notes that I just took. So these are essentially like two ordered pairs, right? So we have -4, 1 and 6, 6. So again, when I have ordered pairs, I'm a fan of automatically labeling them x1, y1, x2, y2, right? So let's go ahead and find the slope. The slope between 2 points, y2 minus y1 over x2 minus x1. Again, this is the slope. So then if we plug in our labels, we're going to have 6 minus 1 over 6 minus a -4. The top is 5. Double negative becomes positive, so the bottom becomes 10. And it reduces down to a half. So that's the slope. So then if we want to plug it into slope-intercept, that's going to be our y equals mx plus b. Okay. So I think we need to still find the y-intercept. We don't know the y-intercept. I am going to choose the second point just because it looks like it might be more simple. So when y is 6, the slope is a half, x is 6. Only thing we don't know is b. So then ultimately our y-intercept, which is b, is going to be equal to 6 minus 3, which is 3. Okay, we got people in the waiting room. You. Let's see, MNOP. Okay, that's fine. and then h. Cool. Okay. All right. Okay. So we got a y-intercept of 3. We can highlight it here. We got our slope of 1/2. So then ultimately we get an equation y equals our m, which is 1/2 x plus 3, right? We get this result. So now before we submit it, we want to check. Whenever possible, we want to check. We want to check our work, right? Make sure it makes sense in the context of the question. Okay, so the original, we want a linear function that satisfies those given values. So when x is -4, half of -4 is -2. -2 plus 3 is 1. So the first one checks out. All right. When x is 6, half of 6 is 3. 3 plus 3 is 6. So the second one checks out, right? So we can be confident. We can be confident in this result. Let's hop over to Pearson. So what we're doing, we made it through the homework for section 1.4 and 1.5. 1.5 went way faster than I anticipated. So I'm going back and working quizzes. If you're just joining us, working on this is quiz for section 1.4. Right, it's just 5 questions. It shouldn't take too terribly long. We got f of x equals 1/2 x plus 3. So 1/2 x plus 3. Simplify your answer. Type an expression using x as a variable. Type your answer in slope-intercept form. Okay, I'm going to go with this. Oh, shoot. I forgot. Yeah, you can't see your result. That sucks. You can't see the result until the end. That's why I only did 5 questions. Choose the correct graph of the function below. So let's see. Notice we have a positive slope and a y-intercept of 3. So it can't be A or D because they have negative slopes. And then C has a y-intercept of, oh, wait a minute. We want a y-intercept of positive 3. C has a y-intercept of -3, so it can't be C, so the only one left is B. Okay. Let me hit next. Okay, we made it to question 2. The table is a complete representation of the function. Decide if it's even, odd, or neither. Even means whenever you have, one way of articulating even, whenever you have x comma y, you also have -x comma -y. Even is symmetric about the y-axis, odd is symmetric about the origin. So let me see, the x's, so notice the x values, the signs are different, but the y values are exactly the same, so that's indicative of even. All right, the signs are opposite, y's are the same, so let's just go with even for that one. Right, if you were to guess, you have a 33% chance of getting it correct just by guessing. The graph of a function is given to the right. 333, that's interesting. Find each of the following. So first let's talk about the domain of the function. Domain is the very left to the very right. All right, so how far left does this graph go? The far left is -3. The far right x value is 8. So this goes from -3 to 8. Okay. And it looks like we include those endpoints, so I'm going to use square brackets. -3 to 8. Okay, the range. The range is going to be the very bottom to the very top. So the lowest y value is -4. The highest y value is 4. So it goes from -4 to 4. Square bracket, -4. And again, I use square brackets because we include those endpoints. We actually reach those values. Parentheses means we get really, really, really close to that number, but we don't include the number. Determine the X-intercepts. Okay, I think before we had to do a calculation, right? Because if you try to eyeball it, it's not, you can't just eyeball it, right? So we need to find the equation of the line and find that X and Y intercept, okay? So let's take some notes. So this is question number is this? Is this number 3? 3, right? I'm also kind of racing against time because I want to at least finish and see how do we do before time is up. Okay. So this is question number 3. So I want to find the equation on the line through those 2 points. We got this -3, -4, and 4, 4. All right, let's hop over to the tablet and see what notes I took. Okay, so we just want to find the equation on the line through these 2 points. Again, my recommendation, label x1, y1, x2, y2, right? Let's start off with the slope. Again, slope is going to be, I'm going to mute the audio real quick. Slope is going to be y2 minus y1 over x2 minus x1 equals in the slope, okay? So then y2 is going to be 4 minus a -4 over 4 minus a -3, right? So double negative becomes positive. All right, double negative becomes positive, so that's an 8 on top. 4 plus 3 is 7 on bottom, so we have our slope. Then we need to find the y-intercept. So if we're going to use y equals mx plus b, right? I'm going to choose that second point just because it looks more simple, no negatives and all that kind of stuff. So we're going to have y is 4. The slope we just found was 8 by 7. X is 4. Only thing we don't know is b. All right, so if we solve for b, we're going to get 4 minus, we get this 8 over 7 times 4. Okay. For 28, so 4 is the same as 28 over 7 minus 32 over 7. What is that, 4? -4 over 7. That's our y-intercept, right? So then ultimately we get y equals 8 over 7 x minus 4 over 7, right? So then if we want the x-intercept, we set y equal to 0. Again, if we want the x-intercept, then we set y equal to 0. Okay. So if we set y equal to 0 and solve, we'll have 8 over 7x minus 4 over 7 equals 0. I think there's a helicopter outside. If we solve, I'm going to add the 4 over 7 to both sides of the equal sign. So I get 8 over 7 x equals 4 over 7. Multiply both sides. You can, dividing by 8 over 7 is the same as multiplying by 7 over 8. Right? 7 over 8. A number times itself, so those become 1, very Zen-like. These 7s cancel. And we're left with x equals, what is that, a half. All right, so that's the x-intercept that we got. So when y is 0, x was a half. Okay, that looks okay. So now let's take this, and we're going to hop back to the quiz. Let me see my time. Okay, we're going to do the best we can with this quiz, because I know we're kind of short on time. Let's see, x-intercepts. We got 1/2. Use a comma to separate. Okay, we got a half. Nope. 1 over 2. Okay. And then the y-intercept we actually found as well. We got a -4 over 7. -4 over 7. Okay. Increasing, decreasing, and constant. So it's increasing as x moves from -3 to 4. Increasing. So as x moves -3 to 4, and for our discussion, we need to use parentheses for increasing, decreasing, and constant. Okay. Decreasing is never decreasing, and it's constant as x goes from 4 to 8, in parentheses. So as x goes from 4 to 8. Okay. Even, there's no symmetry, right? Even means y-axis symmetry. It's not symmetric about the y-axis. Odd means origin symmetry. It's not symmetric about the origin. So this should be neither. There's no symmetry. It's neither even nor odd. Okay. Sketch the graph. So it's absolute value of x when it's between -1 and 0, and then it's square root of x when x is greater than or equal to 0, right? When x is 0, and I think it should be a filled-in circle. So it looks like A, but it needs to be a filled-in circle. So then we're going to go this one, C. Hopefully we haven't made any mistakes that I could. Oh, we haven't. Are you sure you want to leave? No, we need to finish. We did C. What's the domain? So the far left is what, -1, and then the far right is positive infinity. So it should be this one. The range, so 0, I think 0 to infinity. This one. Okay. Okay, I think we got one more. Let me see the time. So this is going to be it. This is like do or die, hopefully. Okay, so this expression is called the difference quotient. Find and simplify the difference quotient. Okay, so we need to write. I'm going to go a little bit fast because I'm trying to get you guys out of here. We're like pretty much at the end. So question number 5, I'm going to say difference quotient. We have this f of x equals 5x squared plus 3x plus 7. And again, the difference quotient is f of x plus h minus f of x all over h. Okay. Find and simplify, right? So if we hop to the tablet, let's find f of x plus h. So we're gonna replace each x with x plus h. So f of x plus h. Okay. That's gonna be 5 times x plus h squared plus 3 times x plus h plus 7. And just so you guys can see it a little bit better as to what we're doing, style blue. Okay. So then if I expand this, I'm going to expand this all the way out. So the first thing becomes 5. We're going to have x squared plus 2xh plus h squared. I use FOIL there. Plus 3x plus 3h plus 7. And then ultimately we get 5x, and I'm distributing here like this, like this, like this. 5x squared plus 10xh plus 5h squared plus 3x plus 3h plus 7, okay? That's f of x plus h. So then, if we put it in the difference quotient, I'm going to just kind of do that so you know I'm talking about a different thing here. So I'm going to say that the first thing, I'm going to say this result minus f of x all divided by h. Instead of writing all that, I'm just going to copy and paste. Copy, paste. Okay, and then when I say minus f of x, I need to distribute a negative. So I'm going to say minus 5x squared minus 3x minus 7. This is all really supposed to be on one line, so I'm going to shrink it down and move it around to get it on one line. Like this. And then this is all supposed to be divided by h. All right, so we're going to say, okay. Oops. I see the time divided by h. Now let's simplify. We should have a lot of things canceling. For instance, this negative 5x squared cancels this positive 5x squared. This negative 3x cancels this positive 3x. This negative 7 cancels this 7, right? So notice that every term remaining still has an h. So let me highlight that. There's an h here. There's an h there. There's an h there. Style like this, okay? So let's factor out that h from each of those remaining terms. So then we're going to have h times, it's going to be 10x plus 5h plus 3 all over h. These guys cancel, and we're left with 10x plus 5h plus 3. Okay, I think that's good. Okay. We're going to submit this quiz and see how do we do. Let's go paper like this. Okay. We got 10x plus 5h plus 3. Let's hop back over to Pearson. Cross our fingers, because if we make a mistake, we're not going to have the time, because we're not going to have class time to correct it, but you know, you guys get unlimited attempts. 5h plus 3. Okay, here we go. Submit the quiz. Take a deep breath. Woohoo! Yay! 20 minutes, right? So I would imagine this would take you about an hour, give or take some time. Okay. So let's hop here. All right. So if there aren't any burning questions, we're actually going to end. Let me check the chat real quick. Yeah, it's okay. I went on to give you, I gave attendance credit. Okay. So yeah, we're going to end the session here. And if there aren't any burning questions, from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.